Welcome to Modern Academic Studies. Today we are starting from the remaining important functions for class 11 students. The first one is a signum function. Okay, see that the real function defined by fx is equal to 1, 0, minus 1. Condition 1 is for all x greater than 0 and 0 is at the origin at x is equal to 0, and minus 1 for all x just less than 0. I have drawn the coordinate axis also. Look at here. First part is not defined for x is equal to 0. So we give a void circle. Here also a small void circle indicating that the graph does not touch on the y-axis. Okay. There is a point in the origin as per this part. Okay. From here we see that at x is equal to 0, y is 0. After that, y is equal to 1 for all x greater than 0 and y is equal to minus 1 for all x less than 0. It shows that the domain R is the set of real numbers. Range will be obviously 1, 0 and minus 1. Okay. Please remember those things. Now we are moving to greatest integer function. Okay. This is the definition and I have drawn the coordinate plane format also. To see the definition, the greatest integer, okay, less than or equal to x. If x is at some integer, then the x will be, that means fx will be exactly that integer. For example, if I am considering this point at minus 2, then y is equal to minus 2. Here it will be, okay. And if I am going towards right, but not exactly at minus 1, then what will happen? We see that the greatest integer value less than or equal to x. So this part is considered less than. So if I am here, then immediately towards the left, minus 2 is the greatest integer, okay? So it will be the value minus 2 for all variable x here. And as we are moving towards the right of 0, then what we see that before reaching to 1, we see that the left side greatest integer is 0. So it will be 0 for all those x. Okay. So y is equal to, it will be 0 always for all. We can write a graph like that. Start from here. Okay. And then as soon as x crosses 1, then by definition, greatest value will be 1. Y is jumping to that value. And then we can go up to that point, but not exactly do that. Okay. This condition is shown by small void circle. Okay. That immediately before 2, y cannot be 1 at 2. When it is going to 2, then it is that. And then going to further away from 2, then it will be going like that. And same way we put a void here exactly on 3. Okay. Similarly here, as soon as we are in this range, then minus 1 will be the value. And here you show a void circle. Okay. Not touching the y-axis. See, this is one more example. Minus x equal to minus 2 or greater than minus 2, but less than minus 1. That will be graph. I hope you understood. So what will be the domain and range? Imagine. See, any x we are able to take, so domain will be the set of real number r, but range will be the set of all integers. Domain of the function is equal to r and range of the function is equal to z. Okay. Now we are studying the modulus function. The real function defined by fx is equal to mod x is called modulus function. Now to understand that one, meaning of this is that x can be positive, negative, anything, but output will be a positive number. How the style of the graph will be, it is easy to understand. So you remember that the identity function fx is equal to x, or y is equal to x. In identity function, you got that one line bisecting the first and third quadrant. So this third quadrant portion is reflected on the second quadrant. Okay, this is the difference because of this actually. Okay, graph will be two straight lines, one in the first quadrant bisecting the first quadrant, and the second one bisecting the second quadrant, both of them starting from 0. Okay, this is the graph of the modulus function. Obviously, domain of the function is equal to real number set R, and range is equal to 0 to up to plus infinity. Okay, next we are moving to algebra of functions. See, algebra of functions, nothing but the addition, subtraction, multiplication and division of real functions. Okay, if fx and gx are real functions, then addition of these two functions means, number one, fx plus gx is written as f plus g of x is equal to fx plus gx, where x belongs to the common domain. It is because these separate fx and gx may not have the same domain, may have different domains, but when they will be combined, then they must have the common domain. That is the intersection of the two domains. Okay, then number two, fx minus gx is written as f minus gx is equal to fx minus gx for all x belonging to common domain CD. Remember like that. And number three, fx into gx is written as fg of x is equal to fx into gx for all x belonging to common domain. And fx divided by gx is written as f by g of x is equal to fx by gx for x belonging to the common domain and gx not equal to 0. Now this format we have to remember, because based on those different questions will be possible. Okay, if you understand the basic things, then you can answer. So now I am going to show you with the help of a graph the basic concepts regarding the common domain and how the graph will be modified in case of these operations. Okay, let f is a function from R to R defined by fx is equal to x square, and g is a function from R plus to R plus defined by gx is equal to minus 5, which is a constant function. To find f plus g of x and the graph of that resultant function and the domain and range of the resultant function. So by your common idea, you draw the graph. This is the graph of the first function, and the graph of the second function is this. Okay, and domain also this one for that, and domain of this is that domain. Okay, and range is only minus 5, and that is range is from 0 to infinity. Okay, quite different things are there. What happens to calculate this one? For this example, these are the answers. F plus g of x is equal to x square minus 5. And then graph is this. Okay, domain, obviously see that the graph is in the fourth and first quadrant, and for all x from 0 to infinity. So domain is r plus, you can write, or you can write like that, 0 to infinity. And range is obviously from minus 5 to plus infinity. Okay, hope that you have understood the total concept of this. Okay, in many tutorials not that much of things are explained. I am explaining very much conceptually. Today we are closing here, and next day we shall start very important problems.